Hi, my name is Nolan and this is my circuit for part B and C. I calculated R1 to be 73.6 kiloohms, and I'm using 4 resistors in series to get 73.8 kiloohms of resistance. I calculated R2 to be 8.3 kiloohms, and I'm using an 8.2 kiloohm resistor. Here's my VN and VB for part B. As you can see, both signals are completely in phase, and the peak-to-peak voltage of VN is about 1, with the peak-to-peak voltage of VB being about 1.3, which makes qualitative sense. They should be about the same, but VB a little bit bigger. Here are my signals for VN and VE. As you can see, the signals are totally in phase as expected, and the peak-to-peak voltage of VN is about 1 volt, with the peak-to-peak voltage of VE being also about 1 volt, which is what we expect. They should be about equal. My signals for VN and VC. As you can see, VC is 180 degrees out of phase with VN because the transistor acts as a switch, so when there's a positive signal, the switch is open and VC potential is negative, and when there's a negative signal, the switch is closed and VC potential is positive. VC has a much greater amplitude at peak-to-peak voltage than VN because there is a gain. The gain is of relative magnitude RC over RE, which is about 10, which, as you can see, the peak-to-peak voltage of VC is about 10 times greater than that of VN. My circuit for part C of the lab, which is the same as my circuit for part B. VO1 or VE is measured via this blue wire here, and VO2 or VC is measured through this orange wire. Here you can see my plot of gain in decibels versus frequency in hertz for VO1 or V emitter. The data was actually supposed to start being measured at 100 kilohertz, which is this line, so everything left of that line can be ignored for now. But you can see that after 100 kilohertz, the gain is relatively constant at about -3 decibels, which is exactly where we want it. And it remains around there until it drops off at much higher frequencies that are out of our measured range. You should also note that there is a phase shift of 0 degrees, so that VO1 is in phase with the input voltage, which is exactly what we expect. Here you can see my plot of gain in decibels versus frequency in hertz for VO2 or V collector. As you can see, the gain of V collector relative to VN is relatively high at about 20 decibels for low and medium frequencies, but drops off at higher frequencies near 5 mega ohms and above. You should also note that the phase shift is 180 degrees, so VO2 is 180 degrees out of phase with VN, which is to be expected since we saw in part B that VC was positive for negative input signal and negative for positive input signal.